With the cloud maturing rapidly into a center of gravity for data and functionality, most organizations recognize the need to optimize their information architecture and redesign critical workflows. Cloud native is the new standard, and it's just in time for leveraging the remarkable power of AI. Find out why on this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Welcome to the future indeed. It's barreling towards us right now all the time. As my favorite futurist, William Gibson, once said, the future is here already. It's just not evenly distributed, at least not yet. Folks, we're going to talk about that today on our inaugural episode of The Connection, AI meets cloud native. What does that mean? What does it mean for you and me? What does it mean for business? I'll tell you what, it means some very exciting times are here. Of course, AI is now front and center in the large organizations around the world, even in small companies. We're talking all about AI. We can thank ChatGPT for that, quite frankly, and Microsoft and OpenAI and lots of other companies, Google with Bard, of course. These things are progressing very, very quickly. It's a very interesting space. AI is not new. Artificial intelligence has been around in one form or other for decades, but we went through a couple AI winters because really the compute wasn't there. I think that was the biggest factor, and the data really wasn't there. You need to be able to train models on data. Now, there are adversarial AI engines that can kind of train each other, so that's an interesting thing to consider. But today we're going to talk with a couple experts, an AI expert, a cloud expert, two cloud experts, as a matter of fact, and dive into what is possible and what does this really mean. So what does cloud native mean? Well, think back just a few short years ago, maybe 10 years ago, and when you went to get a piece of software for your computer, for your laptop or your desktop or your server, for example, you would be given this list of options. Which operating system do you have? Linux, Mac OS, and there were like 13 flavors of Microsoft Windows NT, Microsoft Windows this, that, like a whole bunch of different versions. Well, what does that mean? For developers, that was a bit of a pain because you have to compile for different operating systems, and there are different nuances in each one of these systems, all designed for particular bespoke purposes for sure. But from a development perspective, that's a real challenge. I mean, you already have to design for 2 or 3 in general. And this is one reason why Linux really took off and why IBM invested $1 billion or so making Linux an enterprise-grade operating system. Well, something else happened in the relatively recent past. Google figured out that this is a real problem, and they figured out that the future needs to not worry about that stuff so much. And so they came up with this project called Kubernetes, which has just taken the market by storm. Of course, it sits on top of Docker, so there's a history here as well, a lineage of technologies. But what Kubernetes does is it distributes compute. The best explanation I heard of it is think of little system processes inside containers, little things that a computer needs to do. It floats in a little container, shows up when it's needed, disappears, goes away. That's essentially how Kubernetes works. So what they did is they abstracted away the need to worry about the target operating system, and that's a really big deal. So cloud native really, at least in the Kubernetes world, means functionality that can work here, there, or anywhere. Of course, we have several major cloud providers these days. Amazon Web Services still out front, but Microsoft Azure absolutely nipping at their heels, making tremendous progress in the last couple of years. And of course, Google Cloud Platform is also getting serious, and they're not the only ones. Heroku is out there. There's a bunch of others out there, interesting companies doing stuff. But for you and for your business, what really matters is you want to be able to design software, deploy software, and then augment it with artificial intelligence to optimize things. And we're going to talk about that today. What is the nexus of cloud native and artificial intelligence? And for that, let's bring in a guy who knows a lot about it, Matt McLarty from Boomi. Matt, tell us a bit about yourself and what you're working on and what you think is the real value of the nexus of cloud native and AI.
Awesome. Well, thanks for having me here. It's great to be here. So my name is Matt McLarty. I'm the CTO of Boomi, and Boomi is a leading provider of intelligent integration and automation solutions. We have a platform that's deployed at over 20,000 organizations, been in the space for, Boomi's been around pretty much for the duration of the whole cloud native journey, right? Since about 2008 when SaaS and infrastructure as a service really started taking off. So, I'm working with organizations around the globe, helping them define their strategy for how they do integration, how they leverage integrated experiences for customer experiences, user experiences, automated business processes. What I guess a few months ago we might say companies on a digital transformation journey, but now that ChatGPT took up all the headlines,
Right.
maybe it's now the AI transformation journey. But really, everything that you just described there, I think is sort of this path that we're on in the IT industry, which is continuing levels of abstraction. And so when we talk about cloud native, it's really about these different layers of abstraction. And cloud's one of those terms. We do this all the time in the tech industry, right? We overload words, and I think it's hard to say who was first, right? I guess it was probably like Salesforce and SaaS came into the market as like, here's an abstraction, a new way of deploying software where you've got instead of having to do the install like you described with all the different operating systems, no, we just have the service. It runs out there on the web. But of course, AWS launching mid 2000s really brought it to another level where you could build your own applications, run them in the cloud. And I think since that point, it kind of fueled all these different paths of innovation going on in the we've historically lived in the user-facing application world where you'd have multiple SaaS applications, back-end applications. You need to connect those things. There's a huge migration journey going on there. Companies are still moving away from proprietary installed software to cloud-based SaaS services, or even moving their own deployed software from the on-premise into the cloud. But then you've got the whole SaaS side, and then you have a whole analytics world and the whole big data explosion that happened around Hadoop and late 2000s as well. That's gone on a whole other path where now Snowflake and other providers have turned the whole analytics industry into a cloud native industry as well. So when we talk about cloud native, I think probably most of the people that hear that term would think Kubernetes and the container ecosystem and what's happened in terms of the abstractions going on in the engineering of software. But at a higher level, cloud native is just about having those abstraction opportunities. And if you're a developer of software, if you're a user of software, just taking away as much of the implementation complexity that you don't need to worry about and really delivering you the most seamless experience as a consumer or user of technology.
Yeah, that is such an excellent point right there. You're abstracting away the technical details so you can worry about building software for your business instead of worrying about connecting the dots again and reconnecting the dots and reconnecting the dots. I mean, the amount of time that was spent historically just keeping things operational as the world changes around you was really difficult. And that has largely been resolved now because of this general agreement to go to cloud native. And it does require competitors to kind of work together. But the beautiful thing, and I think open source has a lot to do with this, quite frankly, because the spirit of open source said, look, let's all collaborate on the foundations, and then each of us can build out our unique characteristics and functionality that makes our company special, right?
Yeah, I think, I would say this, going back to the Gibson quote you started with, right? The future's here, but it's not evenly distributed.
Right.
I think the potential is here, but it's not evenly distributed. There's a tendency where I find engineers are optimizers by nature. And so a lot of the times, even when they have the opportunity to say, forget about all that complexity underneath, just build what you want to build, they still like to tinker away with the, I think we can make that wheel spin a little bit faster. Let's reinvent that wheel one more time. So that's just to say that I think that one of the things that's really important in the world of cloud is constraints. And constraints come in different forms. So open source is an interesting example there, because open source is at the code level. It's very wide open in terms of what you can do. I find that can lead to a little of that tinkering I was describing that may be superfluous. But APIs play a huge role in the cloud native space. And I think if you look at Kubernetes, if you look at AWS, if you look at all these different cloud-based services, APIs are usually the demarcation point between the consumer and the provider, and the place where you can hide all that, you can abstract away all that complexity that's unnecessary for the consumer side. And I've been, focusing on API design best practices for a long time. Again, there's ways to design good APIs that are durable and abstract things. S3 and AWS is probably a great example of that, where they launched this API in 2006 and it's hardly changed in 17 years. And then there's other examples where maybe the complexity bleeds through. But definitely for organizations that I've seen really taking advantage of the cloud native opportunity, that's what they're doing. They're really using the demarcation points and the constraints and the abstractions to help people move at the fastest speed they can to get their jobs done.
Well, yeah, and when the target stays the same, that allows you to practice and get closer to perfection. But when the target keeps moving, when the goalposts move, that really affects every last bit of the process: the planning, the roadmap, the execution, the maintenance. Everything becomes loosey-goosey if the goalposts keep moving. But if at least the target stays the same, then we can marshal resources as necessary, and at least we can track our progress getting to where we want to go, right?
Exactly. And I think, complexity is an interesting word here, where I think a lot of times, and you'll see in a lot of marketing materials in the industry, treating complexity like it's the enemy, right? Complexity is bad. We're going to simplify everything. I think like Fred Brooks did his paper in 1985 or something, talking about different types of complexity. I think the reality is, like, for the most part, look at what we can do with software. The complex problems that we can solve, and we're going to get into talking about AI, where it just takes it to a whole other level, right? It's really the organizations I've seen that work most effectively are the ones that understand that they have to make complexity their friend,
right?
And really learn how to tame complexity, right? Take the wild beast and have it, working for you as opposed to working against you. And a big part of that is delineating, like, what's the complexity that we're solving for versus what's the complexity that we're introducing in the solution. And so I think with cloud, that's why it's so powerful, is we could never invent a single appliance that was going to hide all the complexity inside a box, right? But with cloud and all the levels of abstraction that we have, and the way that we can interconnect, the things that we can do in an interconnected way, allows us to dance with the right complexity and kind of and not bleed over too much of the complexity that we don't need. But to your point, like, it's a potential, it's always a potential house of cards, because and that's why I think embracing complexity is an important thing for organizations to do, because if you pretend that it's gone,
right,
like this is like the fallacies of the network, right? It will come back and bite you.
That's right. I love what you said. Dancing with the right level of complexity. That's pretty cool stuff. And you gave me a great segue to bring in Mike Bachman, head of architecture and AI for Boomi. Mike, so I'll bring you in. The beautiful power of AI is, again, if the target stays the same, then we can build our intelligent automation, our intelligent analysis around all that. Let's go to Mike Bachman. Actually, William McKnight is on the screen here. I'll get some quick thoughts from you. Go ahead.
Okay. Well, I like what was said about cloud native. I do want to stress that it's more than just cloud computing. So it's more than just utilizing the cloud for all of the benefits that you get from the cloud, where you don't have to have your own data center and the staff that goes along with that and all that sort of thing. But you get access to a wide variety of resources, which is great. But to be cloud native, you go beyond that, go beyond your lift and shift from your on-prem to the cloud, and you get into some of the things that we're talking about. Specifically, the broad term is microservices. And so to get there, you have to take your code, your historical code that is probably not in microservices, but take that and shrink it down into manageable bite-sized pieces where each piece does a very finite function, orchestrate them together with orchestration tools like Kubernetes was mentioned, make sure that everything is containerized. And this gives the code ability to be portable and manageable across all environments, as you have been stressing, Eric. But also, I think, take full advantage of the cloud and be cloud native. You have to be agile, and you have to code with CI/CD, as we say, or continuous integration, continuous delivery in mind. And that will help allow you to take full advantage of the cloud capabilities for your applications. And your DevOps should be more streamlined as well around this CI/CD concept. So putting that all together, it's not for everything in most enterprises, but a lot of development is going that way, or it might be going to a place where you still got your on-prem and you're adding on to it in the cloud is sort of a hybrid cloud fashion. So while I wouldn't call cloud native a current standard, I would say it's a great best practice and a definite trend.
We were talking about AI and your data and on-prem data centers not going away. And I'll throw this one over to Mike Bachman, because you know a thing or two about all this. I mentioned you don't want your data training someone else's AI. Of course, that's what ChatGPT did. And there are now some lawsuits out there, and it's going to be interesting to see how that pans out. But you got a lot of experience in the space. These are amazing times. What are your thoughts about this nexus of AI and cloud native?
Yeah, so first of all, Eric, thanks for having me on today. This is a lot of fun. The conversation's been great. Where AI is going, you know, I loved where you left that off, because I often say, do you want your IP training somebody else's IP? And interfacing with cloud-based, you know, machine intelligence services, such as something like ChatGPT, Bard, Claude. There are different ways that each of those different SaaS services uses their foundation models under the covers. But some, you don't know exactly how your data is being used, in spite of the fact that there are different governance tools that each one of these types of services offers. Still, it's something that we're all impressed with. ChatGPT really changed a lot. It brought into the zeitgeist, you know, this concept of something that feels very anthropomorphic, something that feels like we can talk with a system of computation and get back something of value. And so it becomes seductive, I guess, to want to interface with it. But I think if we use it as a system of production, or to put something like a generative pre-trained transformer in a large language model in a typical data pipeline, we might want to think about how that use case really plays out, what type of governance needs to be thought through, and then what ultimately our desired outcome is from that particular use of this technology, because it's really, really neat stuff. However, it's just scratching the surface.
Yeah,
So-
you bring up an excellent point here, which is to remember, what are we trying to accomplish, right? And I think one of the hurdles that organizations will have to get over here, and it's happening in fits and starts right now, is how do we open our minds to Total Recall, open your mind. Remember Arnold Schwarzenegger?
Yes.
But how do we open our minds to this new set of possibilities? Because there is a tendency to do things the old way and to get accustomed to our constraints that we have. Well, those constraints are now largely out the window. So you always want any focus you have about leveraging AI to be bordered and driven by some business need. What are we trying to accomplish? Do we want lower costs? Do we want a better conversion rate? Do we want to better understand the customer? And then let your team run wild in terms of coming up with how to leverage it. Give them a sandbox to play with, to do something, but be careful, have the guardrails. Do this in your on-prem environment, for example. Don't just throw it into one of these large language models, but focusing on the business outcome and then using these technologies to get there, that's the key to success. What do you think?
Yeah, I agree with all of that, more or less. And I think, you know, the idea of being, you know, at the nexus of where the art of the possible and the reality of the feasible meet is sort of where, you know, both Matt and I have spent much of our career. And with that comes, you know, new and emergent technologies, such as these really sophisticated sets of computation, artificial intelligence, or I like to refer to it as machine intelligence, because I don't know what intelligence is, whether something's real or artificial. That's a philosophical conversation. But that said, using machines and these levels of computation that give us scale and give us speed that our puny human brains can't possibly fathom, you know, this is really powerful. And so before we use a powerful technology, we probably want to test it out in a sandbox environment. And one of the things that I love about how you're bringing together the conversation between cloud native and artificial intelligence is because I see them go hand in hand. In terms of agile process, microservices, all of these things, I think where the state of AI is today is really built on, sort of the shoulders of giants. And the ability to have computation at scale, the ability to have memory systems and networks at scale as we do today, happened iteratively for, really 7 decades. And this was sort of the Turing's vision was what we're now realizing, where a system of computation is actually capable of feeling very human. And so if we think about how, data evolved or information connected with, with these different systems that we've built over the course of the last 7 or so decades, we're at a point now where we get to see just the incipient phases of where AI or machine intelligence could take us. And so to use machine intelligence inside of our processes can be really, really seductive. And so it's important that we really think through all of the realm of possibilities that artificial intelligence can give an organization, look at our use cases, and really become ready to receive AI in ways that we haven't. In fact, right now we're developing whole programs around AI readiness, because this seems to be where folks want to know, where can I use ChatGPT? Is ChatGPT the only thing I can use? Short answer, no, it's not. What are these models that I can take advantage of? Do I have to go through a SaaS service to use them? Yes or no? How do I make sure that I can trust whatever this AI engine is giving me? Because I hear it hallucinates. What does that mean? How is that relevant to my business?
Right.
These are just some of many concepts that we have to think through to become AI ready.
And I'm so glad you brought that up. That is a huge issue to tackle. AI readiness. Are you ready? Is your data ready? There's a whole side of the equation of being able to understand what is the corpus of your corporate data. You've got 20% maybe that's structured. It's probably more like 10, which means you've got 90% unstructured data. It's in documents, PDFs, spreadsheets, emails, all sorts of unstructured data. Well, guess what? That's the context for your structured data. Now, when the executives read reports, they kind of know the general context, but machines don't, or at least don't yet. And they won't until they start crawling around in your data. So you need to be ready to use AI. And you made another really interesting point here I'd like you to expand upon, which is we're not really going to know until we play around how these things operate and what they do. And if folks who haven't done it yet, you should definitely start playing around with these large language models, just the different prompts you can get. We did a whole show on that last week about sequential prompts and strategically aligned prompts, basically, and you can give lots of details. And then of course, there's the embeddings. When you embed your data either into a vector database, for example, or right into a model, those are the anchors of truth, as Brian Raymond referred to it, a guy we had on the show last week. I love that concept, anchors of truth. But you need a skunkworks team to play around with this stuff just to hash out the range of possibilities of what's going to be plausible to spend your time and effort on. And if you do that carefully, what was Eisenhower's line about planning? I've always found that plans are useless, but planning is indispensable. You're going to learn a lot by playing around with this stuff, right?
Absolutely. And I do want to talk about something you just said. And that is, I'm glad you had a conversation about embeddings and vector databases last week, because really, people often ask me, what changed? How did this thing come to be? Was it in November when ChatGPT was introduced? It seemed to come out of nowhere. Well, if you've been in the space, in December of 2017, there was a paper that came out that was sort of seminal for where we're at today with something called transformers. And since you had the conversation last week, we'll have your listeners go back to that. But really easily to distill what changed is humans no longer have to think like computers in order to retrieve information. Now the computer, we can offload that function to the computer to do this. And so these anchors of truth that your previous guest had talked about is exactly that sort of thing, wherein instead of us having to think in terms of SQL statements or compute logic or and or gates, we can now ask in our own native languages, whether that's English, German, Russian, whatever. You can ask in your own native language a query, a question, and you can get a response that really sounds relevant to whatever the answer is going to be. And there's another thing to think about here too. The more that you provide context-based data into that particular question, or you imbue the machine intelligence with relevant data, the better your answers are going to be. And you brought something else up that I want to point out too, which is talking about different types of prompts. I like lazy prompting because what that means is that I can have conversations with the machine intelligence system that I'm talking to, whether it's Claude, Bard, or ChatGPT or something else, and be able to ask a very simple rudimentary question about a particular topic, and then riff with the computer until I come up with the answer that is sufficient for me. And so I don't need necessarily, and certainly over time, I do not anticipate that these systems are going to require a well-prompt engineered sort of input in order to achieve a desired outcome. Instead, what it's going to require is domain efficiency with the kinds of questions that you're asking, and the ability to have two interlocutors, one human, one machine, being able to riff off of each other until a defined answer is achieved.
Yeah, lazy prompting. That's brilliant. It's like the open-ended question, right? Maybe I'll bring, let's say I'll bring Matt McLarty back into the conversation. The point is, you have to play around with these things to understand how they work. It's like I got back into playing ping pong and reminding myself about spin, top spin, backspin. You have to do it a few times before you're, oh, that's right. If he does backspin, I got to do backspin. If he does forespin, I got to do forespin. That kind of thing. That's what you're going to learn when you play around with these things. But there is so much to learn. We've only just begun, right?
Yeah. And, innovation in the technology space is a really, it's a tricky, it's more art than science. Right? And I've been, I think the point was made earlier about really zoning in on the business need. But until you know what the range of possibilities are, it's hard to even figure out what business possibilities you're going after. Right. And we've seen this isn't just a new thing for the AI space, but in any sort of technology domain, like when a new technology comes along, where do you apply it? There can be a huge temptation to just, take the new hammer and everything is a nail. And at the other end of the spectrum, you may be myopically focused on some particular business need. So I think the point about just having people get into that world and play around with it and get an understanding is important. But again, I was talking earlier about the engineering mindset. I think there's almost a creative mindset that's needed to be able to span between practical application and where the technology is. And so I think that's going to be something that, I think the AI has, for the most part, grown out of the world of analytics, right? Data and analytics. It's essentially, this is a massive oversimplification, but it's like code written by data, right? This is kind of, if we were to classify all the AI stuff that's out there. And so garbage in, garbage out. Putting the focus on the data is extremely important. But it's easy because of all the complexity in that world to get lost and forget about, if you're a business evaluating the usage of this technology, how is it actually moving the needle for my business? Where am I going to realize value? And so, I think for companies that are pure play, building new models, doing all the innovation on the AI side, fundamentally important. Where we sit in Boomi is we have a tendency to span those worlds just by virtue of where our platform resides, right? We're going from the data, bringing that to the surface where it's used by customers, for companies, by other user interactions, by automated process that drive the business. So I think this is where we've been able to observe, even pre-AI, other technologies, like where the value gets realized in all of this isn't so much in the latest and greatest model that gets invented, but how does the insights coming out of the models, how do they actually get leveraged in the flow of business to drive the business model for companies?